right, now we are going to turn to the second research panel of the day. I have the distinct honor of introducing Charles Maberry as this session's chair. He is the director of the Industry Initiative, acting director of the Skills for Employability, and head of the Next Einstein Forum at the Global Network Secretariat of the African Institute of Mathematical Sciences, Next Einstein Initiative, AIMS. For the last couple of years, Charles brought strategic oversight and direction to the AIMS Industry Initiative with the aim to broaden the scope and breadth of partnerships with industry in Africa and beyond. Charles's dream is to position AIMS as the industry's leading academic partner in Africa that achieves industry and economic advancement for the continent. We're deeply grateful he's come such a long way to chair this session on AI-informed safety and algorithmic bias. Please join me in welcoming him.
Thank you very much, Sean. And thank you for the organizer. It seems like we're missing some people in our panel. They're still here. Otherwise, we're going to have the whole hour to tell us more about what we're trying to do. Do we still have people online? Because I wanted to also acknowledge an invisible audience. Because do we still have 1,000 people online, or they drop?
We have like 200 people online.
200. That's a big number. Thanks for the introduction. Yes, 17 hours of flight was quite good. Oh, we have our panelists. I'm still digesting the keynote speech before lunch. I think Uwe made us think out of the box, and that's, for me, is really an interesting connection with our panel. AI is not about data. It's also about digital divide. It's not only a statement, but the way you put it, I wish he was around for us to just reflect on that. So this panel is actually taking some of the aspect when you talk about digital divide and AI-informed safety and algorithm bias. I think the presenter want to have a chance to tackle it from two angles. One is for us to address the issue of safety, to ensure that the AI system operates safely, considering factors like data quality and transparency. People mention this kind of issues. So when I listen to the presenter to go a little bit in deep in that. The other one is the bias, especially from some of us coming from Africa. I think if you just look at the two languages, you excluding 5 billion people, my grandmother or grandfather will never be in your data set. So I think it's important for us also to look at fairness issues, try to mitigate the risk, and ensure that we promote safety in AI application that you want to do. So I am pleased to introduce my panelists. We're going to start with Karina. Thank you.
Good. So I think earlier this year, I had quite some fun with the Make It More trend on Twitter. And I found this nice thread by one of the users asking ChatGPT to make this beautiful Swiss scenery more Swiss. And I think we very clearly see how the text-to-image model works with certain stereotypes and biases. And some are clearly exaggerated, right? The Swiss would never build this giant cheese tower in the middle of a market square because it would not be durable enough. But I think in this case, most of us can see those stream of images as something funny and enjoyable. But there are clearly examples where it's really scary to see how those biases and stereotypes play out. As pointed out by this Bloomberg article earlier this year, stating that ChatGPT would actually favor some CVs just because of the name put on top of those CVs. And I think in this room, we all agree that whenever automated systems interact with humans, we have to make sure that the welfare and dignity of all users and stakeholders is met. And I think my and my co-author's opinion is that the first step towards reaching this goal is actually to measure potential performance biases in those systems. So what we do in this paper is that we measure bias in the social judgment of human faces in a vision language model. The vision language model that we evaluate is CLIP. It's an OpenAI product. And what it does is that it connects images with the language. How exactly does it do that? So given an image, the model can predict the most likely text prompt and vice versa. And it does so by calculating the cosine similarity between those two entities. And it's this cosine similarity that we use as a bias metric in our paper. Let's look at those two entities in more detail, and let's start with the image embeddings. So two commonly used data sets in computer vision are UDK face and fair face. And what you can see already from those few sample images is that there is ample variation in those images with respect to the pose of the face, the lighting of the face, or the facial expression. And this is why we choose to work with a third data set, which we call causal face. It was introduced by Liang and colleagues earlier last year. And what the authors do to generate this dataset is that they set a random seed in a generative adversarial network and expand via latent space traversals from this random seed into several directions, such as age, gender, and race. And they do this for several pseudo-identities. So this would be one identity, this would be another identity. We refer to this set of variables as legally protected variables. But a really nice characteristic of this dataset is that the authors also vary a set of non-protected variables, such as smiling, lighting, and pose. And this really gives us a very unique angle towards bias measurement. So now let's have a closer look at the text embeddings. So the text embeddings we construct in a theory-driven way, and we make use of the two most leading theories in social psychology to quantify human stereotypical cognition. So some of you might have heard of Susan Fisk's stereotype content model, which proposes that there are two dimensions across which humans sort stereotypes. So a surgeon is commonly referred to being low in warmth but high in competence, but parents are high in both warmth and competence. There is a new model, the ABC model. It introduces 3 dimensions, and for each of those dimensions, it introduces positive and negative valences. So each of those dimensions is described by a set of adjectives. For example, the communion dimension would be described by friendly or unfriendly, and it's those valence items that we enrich our text prompt with. So in a nutshell, what we do is that we deploy an experimental data set, combine it with theories of social perception, and investigate the embedding space directly. And it's the combination of those 3 angles that makes us capable to make a contribution to measuring bias. So remember that causal phase varies protected attributes, but also non-protected attributes. So the first question we ask, how does this variation actually compare? And in order to do so, we take a bootstrapping approach. So we would always sample 2 images from a certain category, calculate the cosine similarities, and then generate a distribution of those differences. And here we plot those distributions separately for protected and non-protected attributes. And what we see is that seed variations introduce most of the variations. So remember, seed variations are those pseudo-identities. And it's not surprising that they introduce ample variation. It's followed by variations in race. But what was actually quite surprising is that gender does not introduce more variation than variations in facial expression. And similarly surprising, I found, was that age does not introduce more variation than pose and lighting variations. So I think this is already quite an important result that shows that we must not neglect those unprotected characteristics to measure bias, because they could introduce serious confounds in our measurements. So next I want to talk a little bit about age discrimination. And I want to do so while using one sample social dimension, namely the agency dimension. It has positive valence attributes and negative valence attributes, such as powerless, dominated, or passive. And what we do here in this plot is that we plot separately intersecting groups by gender, race, and age. And note that age variations here are plotted via different sizes of the dots. And what we see for UDK phase, one of the 2 in the well-collected datasets, is that those covariance error ellipses, those gray ellipses, largely overlap. So we cannot really disentangle those intersecting identities. a similar picture arises for fair face, but the image is clearly different for causal face. So here those ellipses move apart. And what we see is that males and females, so pink and blue, are almost perfectly separated. But what was also very surprising to see is this almost perfect ordering with respect to age, from the youngest to the oldest individual. So this was so interesting that we here transform this representation, now plotting age on the x-axis. And what we see for most intersecting identities, for most gender race groups, is this increase in positive agency perception with age, with exception of one group. This group has a vastly different trajectory, and this group are Black women. And when we look at more social dimensions than positive agency, we actually see that this trend repeats within the warmth dimension and also within the positive communion dimension. So far, we interpret this effect as the strong Black woman ideal being reinforced with age. This has been reported in human subject research, but if any one of you has alternative explanations, please point me towards those. I would be interested in hearing them. So another interesting exercise that we can do is to compare those age trajectories across the 3 different data sets. So remember, for causal face, we have those U-shaped trajectories, but we do not find those U-shaped trajectories in the 2 wild-collected data sets. So there are several ways to interpret this result, but we favor one interpretation, and we actually think it's not surprising, given those images that I've shown to you earlier, that we cannot clearly disentangle intersecting groups in the wild-collected datasets, and we think this is most likely to be driven by efficient noise reduction in causal phase as compared to fair phase and UDK phase. So given that we saw such interesting results with respect to age discrimination, we wondered, how does this image look like when we look at different facial expressions? So remember that causal phase provides us with the whole panel of different facial expressions across all gender and race groups. So what we do here is that we plot the different facial expressions on the x-axis, and we see again that most, or actually in this case all, intersecting groups behave similarly. So the more this image smiles, the more highly correlated, or the higher is the cosine similarity towards a positive social perception dimension. And this is intuitive, but I think what is again standing out is the group of Black women, starting actually at the lowest distance value, but having the steepest slope. And this steep slope is again observed in multiple social perception dimensions, not only warmth, but also in competence, positive communion, and conservative belief. So we found this is a quite interesting result that I have not seen reported before in the literature. But again, if some of you have pointers, I would be happy to receive those. So of course, our study is not without limitations. The first one I want to mention is that manipulations such as light and facial expressions might have different levels of effectiveness across certain demographic groups. And this was actually checked for by the authors of Causal Phase, by Liang and colleagues, via human annotations. But of course, those annotations are never perfect. This is a step, I think, into the direction of improving bias measurement. But as said, it's never perfect. Another limitation I want to mention are potential residual confounds. So despite controls for background clothing and hair color, some confounds might still be present in causal phase, such as with respect to average image color. And the last limitation I want to mention is that we only investigate one clip model, so we cannot disentangle data set versus model bias. But overall, as said, I think with this highly controlled experimental approach, we can make a contribution with respect to bias measurement being more precise. So let's recap. What did we find? So we find that the impact of protected and non-protected characteristics is comparable in size. So therefore, we make a claim for those characteristics not being neglected in bias measurement. We find that with respect to age, we see clearly clustered gender race groups in causal phase, but not in the two wild-collected datasets. We see a strongly diverging age trajectory for Black women, and we also see that with increased smiling, Black women are more closely to positive social perception. So that's it. Thank you.
Thank you very much. We want to proceed with the next presenter, who is going to take, as he said, please take a second look, improving labeling quality of toxic content using Node. And thanks, Son.
This is your
No,
code.
that.
And do you want to start with
Yeah.
that?
Flight. This one.
So just switch.
Okay. So sorry, what was that?
Just to
Okay. Sure. Thank you. So thank you so much for coming to my talk. My name is Hoyan Kwon, and I'm from University of Maryland. This is a joint work with Jessica Clark, Jui Ramaprasad, and Ilhorn Han, who is my co-authors. So today we are going to talk about how to improve the quality of the labels that are used to train the model and evaluate the models. So we all know that there are so much powerful models nowadays. And we all know that the crucial step in improving the performance of these models is to have a better data. And we all know that still the human label data set serves as a gold standard for training models and assessing their performance. So the goal of this research is to see if we are doing good enough, and if not, how can we improve the quality. Before we proceed, let me just start with this simple example. So there are questions so these labels start like these simple questions. So how many of you think that the picture is actually representing cat? How many of you think this is actually a dog? Okay, there is actually a clear consensus about what this is. Is it a dog, cat, or dog? So now, but there are some questions that are more complex. So for example, look at this picture. How many of you think this is beautiful?
Of course.
How many of you think this is not beautiful? So clearly there is a divide. By the way, this is forest after the fire. So actually the beauty is in the beholder of the eye of the beholder. So the point we are trying to make here is that there are three different types of the labels you can create. In one side of the extreme, there is a ground truth. It is very easy to make a question, answers, and there is low effort to correctly answer it. In the other side of the extreme, there is a disagreement in label where there is no clear answer. So you cannot create the better label. However, in the between, there are controversial labels where clear answer exists, but there is a high disagreement. What is this? So let me show you an example. So this is a little bit complex topic. So if you can get your phones or get your laptops and then actually get the Mentimeter, then how many of you think this is sexist and how many of you think this is not sexist? Okay, so I will just turn this to the platform and okay, how many of you answered? Sorry, I will just wait like until 50 and then show you the results. Oh, sorry. Oh, my bad. Oh. Oh. Sorry. Okay. There is no technician here. So now.
Just go back on your slides.
Yeah. Cool. So yeah, I will go back again. Okay, still 48, 49, 50. Okay, great. So as you can clearly see, there is some disagreement. 20% agrees that it is not sexist, and 70% agrees, 80% agrees that this is sexist. But what happens if you actually label this in the MTurk? We label this with 80 MTurk workers, and the 52% said this was sexist, which means that 48% said this was not sexist. And the reason why this is sexist is clearly because this is actually reinforcing the gender role. But it is very often very hard to get it without thinking clearly about what this actually means. So the goal of this research is not about the ground truth, it's not about the like blue, red ones. We are trying to move the controversial labels, which is in the middle, to closest as a ground truth. But you may ask, what is the problem with this labeling? Is it because you are not following the best practices, which is getting high-skilled experts, employing multiple workers, and set clear goals? So is the best practice all we need to get the high quality and reliable labels? So let me just introduce our research question. Are controversial labels a result of not following the best practices? And can we improve the quality of the controversial labels? So let me just quickly show my first experiment where we had 80 labelers in MTurk, where we leveraged the public available label data set, call me sexist, but. This is data set that is coming from the real life Twitter account. The difference between this data sets and other data sets is that while other data sets statements are usually very simple and clear in distinction about what is sexist, what is toxic, these sentences are a little bit more complicated. So we asked each of them, is the statement sexist? And we constructed the statements in the way that we can represent different types of sexism. So there is we selected 7 statements that are benevolent sexism, 6 statements that are declared they are not sexist in the data sets, and we selected 7 statements that are hostile sexism. But what is benevolent sexism and hostile sexism in the first place? So this we go to again the Fisk that we just mentioned again. So this is a Glick-Fisk, which is ambivalent sexism. There are 3 types of sexism classification that we can make. One is hostile sexism, where there is a clear distinction between the negative evaluation. So women should not be allowed entire freedom of choices of their occupation. It's clearly sexist. No one will argue with this. In the other hand, there is not sexist ones. Things that are worse than normal. This is the new normal. Please adjust accordingly. So there is some context here, but clearly this is not sexist, at least. In between, there is benevolent sexism, like we just saw. Even in this room, there are who are actually very sensitized. There are 20% who was telling that this was not sexist. And in the real life, if you actually label them, there's 50% chances that people will say this is not sexist, although it is clearly sexist. So again, this is the result that we get for the 80 MTurk workers. So there is benevolent sexism, which is yellow, hostile sexism, that is red, and not sexist, that is green. And if you see the labels that are in the y-axis, that is the percentage of people who said it was sexist. Clearly, no values goes over 0.9. And no values goes under 0.1 as well, which shows that there is a controversial labels. So let's think about what this actually means. So usually, when we label the sentences, we would hire 3 workers and ask them and get the majority opinion as the label. If there is a 70% agreement, disagreements that we just saw, then the chances that the ground truth agrees with the population is around 80%, which means that 20% chances there are errors. And what does it mean that you train the model with this 20% error rate and get 90% or 99% accuracy? What does it mean that your model actually performed in 99% in this data set? So there is a lot of things we have to think about what this is. So if you want to, so just in case we want to evaluate, let's say that there are less than 20% chances of error is in the disagreement zone. Because if you take 10%, there is only one sentence statements that actually pass this framework. even with the 20% error rate that allows us, that allowing 20% error rate, only 2/3 of the statements, more than 2/3 of the statements were in the disagreement zone, which means that the sentence, depending on the context, can be really hard to evaluate. And this is actually showing that this will increase the error and bias in the evaluation of the large language models, as you just saw. So can we improve this? Can the nudges help? So this is just, due to the time constraints, I will just simply go on one experiment that we show the importance of the nudges. And in the various nudges we can take, we are introducing one priming, which is methods that activates the representation that influence subsequent judgments. It is complex, but basically what we did was we asked mTurkers, before labeling the sentences, to imagine the life of someone from a marginalized group, write a short paragraph describing one or two things they might do in a day. This is one of the statements that are used to evoke cognitive empathy, so you can empathize on other people. So there is still 80 mTurk workers. Treatment group wrote a paragraph before labeling 20 statements. Control group labeled 20 statements and did not write any paragraph. And order of statements were randomized for both groups. So to show you the results, compared to the blue line, which is the control group, and there is benevolent sexism, which is yellow one, and hostile sexism, that is red, and not sexist, that is green. The priming clearly increased the percentage who correctly labeled this as sexist. Then you may question, okay, but you're actually telling them to write is sexist, aren't you? But in the not sexist statements, actually, labelers correctly identified that it is not sexist and decreased the statements, which clearly shows that this is not through the channel. Our work is not through the channel of making them to answer that it's sexist, but to actually asking them to think through what it actually means to be sexist. So we actually did different ones for male and female, because as we all know, male are less sensitized than female in this, especially in the sexism. So especially for males, as you can clearly see between the changes, males benefited a large more benefits by getting this priming before the labeling. They became much more correct, and much more correct, not only in the sexist ones, but also in the not sexist ones. But in females, there were some it was not always effective. For some cases in a benevolent sexism, females actually answered in the opposite way, possibly because while they are already sensitized, they became more generous against the statements in identifying sexism. So that can be one problem with the statements. But still, overall, even for the females, this increased their accuracy, even for the sensitized workers who already are very familiar with the sexisms. So as a conclusion, we show that the controversial label exists and can introduce bias in model evaluations. We also show cognitive empathy priming is effective and can improve the quality of the workers' quality results of the males. There were some problems with the female. There were some exceptions for the females, but it also increased their performance as well. And there are diverse ways we can improve. For example, we can use this for climate changes labeling, or discrimination based on the race, ethnicity, religion, and diversity and cultural aspect as well. So this is all I prepared, and thank you so much for listening.
Thank you very much. Thank you very much, Song. The next speaker is Daniel, who's going to share with us more about hate speech detection in limited data context using synthetic data generation. Thank you, Daniel. Introduce yourself, maybe. Okay. Yes.
Okay, thank you. Does this work? Yes. Okay, I know we've had a long day, and no one wants to hear about hate speech after a long day. But I think it's important that we have this conversation. Luckily, I don't have many examples of hate speech in my slides, so you're good. We're just going to talk about how we attempt to address these issues. So my project looks at how to generate synthetic data for hate speech detection. Luckily, I'm in a room of people interested in development work. So it's pretty easy to motivate why we need to detect and address hate speech. Broadly, definitions for hate speech are not universally accepted because it varies from one country to another. But we see certain similar trends across countries, right? So like in some of the articles that I've added to the slide, we see countries are concerned about the potential for hate speech to lead to violence. We've seen actual real-world violence in countries like Ethiopia, Myanmar in recent years. But we see also that countries are interested in tackling these issues even in cases where they do not necessarily know how to. So it begs the question of if countries think this is problematic, who should be responsible for addressing the problem of hate speech? The question comes, should public sector the public sector be responsible for addressing hate speech? And often what we found is in the countries where hate speech regulation and hate speech systems are most needed, governments often do not have the incentives to address this problem. And we can go at length talking about some of the issues, but one that certainly comes to mind is that in some countries, governments benefit from hate speech, especially when it's a ruling group against a minority group, as we've seen in some countries. And when we look at the private sector, we could also go at length talking about why the private sector often does not address this problem adequately. When we look from the point of platforms, from the panel today, we talked about how platforms like ChatGPT does not work well in many languages around the world, and there's not as much incentive as you would find perhaps in addressing that problem here in the West, because of course platforms often want to make profit. So what we see in practice is that most of the people doing this work tend to be civil society organizations, broadly defined, right? So this could be nonprofit, could be faith-based, could be academic, but what we've seen in many of the countries in the global south is that the government is not doing much, platforms are not doing much, so civil society organizations do the brunt of the work. The challenge with this is that these organizations are already overworked, they are under-resourced. In some countries, we find just 6 people trying to go through social media and flag things, and that's going to get very tiring and boring very soon. So it begs the question, how might we be able to technologically support the work that civil society organizations do to address hate speech? And like we've talked about all day, the first question that comes to mind is AI. And with AI, the question that comes again is, how do we get the data? So we tried to do this in Myanmar 2 years ago, and we worked with civil society organizations to annotate data for hate speech. And what we found is what I have there. It's a very challenging problem to try to curate hate speech. It takes a lot of time to get it right. It takes a lot of time to actually train the people who would annotate and then try to get them to agree, and then all of that tends to be very expensive. By the time you're done, people have complaints about their mental health because you're asking people to look at horrible stuff for days and weeks. And in the end, the returns are often very poor, right? So you could have people look at 10,000 posts, and then maybe just 200 of those will be positive examples. So it's not super useful for the task, even after going through that. So my experience in Myanmar helped me ask the question, can we synthetically generate data for training hate speech models? Can we reduce how much exposure people have, basically? But just before I summarize the results from this study, some quick terms you would hear: high resource language, and there's a lot of digital data, lots of hate speech data, low resource language, very few digital data. In many cases, no hate speech data sets, like in Burmese and Amharic. I use the word limited data context here. What I'm referring to are these languages are not necessarily low resource in the sense that they have digital data available, but they do not have hate speech data sets available. So the same problem that arises for low resource languages would arise for the limited data context as well. And when I mean synthetic data, I'm saying we can automatically generate the training data for the model. So our approach here is to generate data by leveraging a high resource language data set and transforming that to a mode that's useful for a limited data context. So the intuition here is that there's a lot of data sets for hate speech detection in languages like English. Again, like Uyi said earlier, lots of the focus has been in languages like English. How can we transfer some of what we've learned in those languages to some of the other languages that we care about? And our focus was Vietnamese and Hindi. So our core contribution here is we're going to try 3 data augmentation methods, and we'll see what happens when we apply this for fine-tuning models. The first method is what you would typically use in practice, and that's machine translation. So you take a bunch of hate speech examples in English, you pass it into a machine translation model, and then you get translations in Hindi and Vietnamese. You can imagine that some problems would result from this because machine translation models have no ability to transfer context. They're simply transferring, translating words. The second thing we tried to do was, at the time, again, it connects to the panel that talks about the importance of open source. The open source model that we used for this project is the Bloom open source model, one of the earliest large language open source models. And we were prompting the model, so we'll give the model 5 examples of actual hate speech and tell it to generate one for us. So we were augmenting by text generation. So these are 5 horrible examples, give me one back. And we use that to create a data set. And the last data augmentation method is one that I introduced. And this came from our experience in Myanmar, that oftentimes the problem with translation is that you're unable to transfer specific words that have special meanings in the context and the destination context. And so the way we try to address this is we create 2 entity tables. So we take hate speech data set in English, we create a set of entity tables describing entities in that data set, and we create another entity table in the destination language. So if you want to convert to Vietnamese, you create an entity table in Vietnamese, and we do an infusion of context into a hate speech data set in English. So think of an example where hate speech has been targeted at somebody in the United States based on their race. We can change that specific example to be targeted to somebody in Nigeria based on their tribe. So we are keeping the hate target, but we are changing the context for which that hate speech is targeted. So for training, you'll find details in the paper, but we took 100 original hate speech posts, and we were augmenting the hate speech posts with the synthetic data generated using these 3 methods. The details in the paper, but I'm happy to answer any question about that. For the results, to the left, you would see the 3 different augmentation methods that I described. The first one at the top is if you had actual hate speech data, 400 hate speech data. And the bottom three are the machine translation, the quantity, the context substitution method, and the language model method. If you had 100 original and you were adding these 300 synthetic examples to the ground truth, and you see the same example for the other column. So we have 100, and then we had 250 synthetic, or you have 100 and you have 350 synthetic. What we see, interestingly, is this sort of inverse relationship in the performance. So the contextual entity substitution method does well when you have a comprehensive entity table. So the size of the entity table would influence the diversity of the examples that's generated. So pretty intuitive. And that leads to better performance. So we had a more comprehensive entity table for Hindi. And we see that the augmentation based on the CES method outperforms simple machine translation and Bloom. For sure, we see that machine translation is not the way to go, even though that's basically what's mostly used in practice today. And the converse finding here is that for Vietnamese, we see that the performance for the language model is better than the contextual entity substitution. And that's because in Vietnamese, the data for the language was most represented in the large language model we used. So we see this converse where a comprehensive entity table would make the substitution method work well. Better representation in the large language model will make the generation method work well. So our key findings from this work is that the machine translation method, of course, as we've seen, performed worse of the three data augmentation methods we've seen. We've also seen that the contextual entity substitution method is effective for this context transfer, but it depends on how comprehensive the entity table is. And for the large language model generation method, it depends on how much representation a language has. That would determine the quality and diversity of the generated output. Some big takeaways, just branching back out to where I started from. I believe that in many languages around the world where there are no or very limited ground truth data, we can explore data augmentation as a technique for improving the amount of examples we use for training models. I think, just like Uyi was saying, LLMs will play a vital role, and the types of LLMs that I described here are specialized LLMs, just like he said, that would be useful for both the translation aspect and the entity substitution aspects as well. And the third takeaway is that the entity substitution approach can boost hate speech training data in the absence of effective LLMs. And this work, as we've seen, better representation leads to better outcomes. So it certainly motivates the inclusion of these low resource languages in large language models. Thank you very much.
Thank you very much, Daniel. I hope you are taking some questions, because maybe at the end of the presentation, we'll give a chance to people to ask questions. So the last presentation, I guess Philip is going to share with Samuel. And they wanted to talk about detecting and reducing harmful online content at scale using large language models. Thank you.
Thank you, Charles. Great. Oh, I need the mic. Okay, great. Thank you. So first of all, before starting, I wanted to thank Maria, Luisa, Trevor, and Sean for organizing this amazing presentation conference. Not just presentation, and also Daniel for doing this great presentation, and also a great introduction to what I'm going to be presenting now, which I'm realizing would have lacked a lot of context without having your presentation as an opening. So today I'm going to be talking about several projects along with Philip that the Dime AI group has been working on in Nigeria in the context of hate speech detection and misinformation that we've been implementing thanks to generous funding from FCDO. So Nigeria is a country which suffers from high level of violence, and this violence is reflected in particular in the social media landscape. And we can see that there is a lot of ethnic tension being reflected in the way people talk to each other on social media. And so we were interested in testing approaches to actually track the amount of ethnic tension on social media in order to see whether it was feasible to build a tracker to better capture offline violence. And so we ended up building this tracker on Twitter, which was able to quantify the amount of hate content shared on Twitter. And as you can see, it spikes when outbursts of violence are actually happening on the ground. And so that was very useful for policymakers who were interested in better monitoring and responding to violence happening on the ground. So you may think, it's very easy to do nowadays with all the amazing LLMs that we have. You just sample a bunch of tweets, you just throw them into ChatGPT or your favorite LLM, and you can build an index of hate contents being shared on social media. The problem is that if you use this approach, it would completely fail in this context. And the reason is that the typical LLMs that people use are very context specific. So they tend to fail in contexts where there is low resource language. So to give you an example, a tweet that would be flagged as containing an anti-Semitic slur by most of the typical LLM used in this context would actually mean something completely neutral in Hausa. And this is a case that we saw in many of the examples as we started working on this problem. So the problem here is really that the text data that's used in most of the major LLMs is heavily biased towards high resource context, and therefore they fail when, as you said, we're missing data from your grandfather and your grandmother to train them. So in order to solve this issue, we ended up building our own LLM and constructing our own fine-tuning and evaluation data set in the Nigerian context. So we actually published our findings in a paper that's currently on arXiv that's being reviewed at ACO. Our model is available on Hugging Face, and our data set is on GitHub. So let me give you a sense of what we've done in this work. So first, we constructed the first evaluation data set to compare the performance of hate speech detection system on representative data. So what I mean by that is that we sampled a very large random sample of 30,000 tweets that we labeled for hate speech detection. And we actually realized that the base rate was extremely low. So people talk a lot about hate speech, which it's definitely a very prevalent problem on social media. But if you actually look at the overall rate of prevalence of hate content, it's actually quite low. The problem is that it tends to be quite popular. People reshare it a lot. And this is actually in the ballpark of the numbers that have been found in other contexts, like in the US. So this explains why most existing hate speech detection systems actually are both fine-tuned and evaluated on biased data sets that oversample the positive class. So people find techniques to create training and evaluation data that contain more positive examples in order to build their systems. And for our fine-tuning data, we actually used a similar approach. So we started with a stratified sample. So as Daniel was explaining, the way people usually do that is, they sample content that have specific keywords. So in our case, it was the name of the main communities being targeted in the Nigerian context, as well as tweets containing specific hate-related keywords. So we constructed a fine-tuning data set of 1,600 examples as a start, and then we implemented an active learning strategy by iteratively sampling additional tweets until we get to a fine-tuning data set of 4,000 examples. And unsurprisingly, what we found is that by employing this active learning strategy, we were able to generate more diversity in our fine-tuning data. So that's what I'm showing in the plot on the right, that as we are sampling more with this active learning strategy, we're finding more fine-tuning examples that do not contain our seed keywords. So what are our main findings? So what we've done is we've compared many different hate speech detection systems across different architectures, pre-training and fine-tuning data sets. And overall, the main finding that we found by comparing all these models is that their performance on holdout data, which is what usually people look at when they evaluate the performance of these systems, greatly overestimates the performance of these systems on random evaluation data. So the holdout performance is what I'm showing on the first column, and the ones on the right column are the performance on random data. So for instance, if you look at the performance of our model, which is the Neja XLMT at the bottom, it's performing the best overall. It's pre-trained on 1.3 billion tweets sampled from Nigeria. It's fine-tuned on the fine-tuning data set that I just described, combining the stratified sample and the active learning sample, so 4,000 fine-tuning examples. The performance on holdout data in terms of average precision is 83%, but the performance on random data is only 34%. So this is one of the reasons, there are many, but this is one of the reasons why it's actually hard to fully automate hate speech and content moderation systems in general, right? Because the actual performance on random data is actually quite modest. So this is the first important takeaway, I think, of this work. The other takeaway is that performance typically improves when you fine-tune on more diverse data. And here, I mean, when you look at the performance, in particular on the active learning fine-tuning sample, when models are fine-tuned on the diverse sample coming from active learning versus the stratified sample, which is much more restricted to the predefined keywords that we selected, we see that overall by fine-tuning a model on more diverse data, unsurprisingly, it performs better in the wild on random representative data set. And so that's also something quite important to think about when you're fine-tuning this kind of system, is the diversity of the examples that you're putting in. Okay, Okay, so I'll go fast. So I actually, before I give the floor to Philip, I just wanted to show you briefly how this system is actually used in practice in an actual experiment that we're running in Nigeria. So what we've done is we've used the best model that we developed in order to identify users that have been sharing hate content on Twitter. And we implemented an experiment in order to reduce the hate content that was being shared. And the way we've done it is that we targeted treated users with a promoted ad that contained a video with celebrities, local celebrities, delivering a pro-social message. And so basically treated users were seeing this video in the promoted ad in their timeline, and we could compare their propensity to post hate content versus control. So just give you a 30-second break from research by showing you what the video looks like. And there is no sound, so oh.
I think it's only on the...
Okay. There is always a risk when you're showing a video. Anyway, I'll send you the slides after if you're interested. So this experiment is still ongoing, but it's not going to the last slide. Oh. Oh.
Posting hate towards other ethnic groups is not right.
Posting hate towards other ethnic groups on Twitter contributes to violence.
Contributes to violence and makes us all less safe.
Let us show respect to one another.
Be respectful of one another. We are
So I'm sure you don't know many of them. I'm told they're very big. I see that they have millions of followers on Twitter. So apparently, they're very impactful. And in fact, what we're seeing in our results, and it looks like this is not working. I'm not able to show the last slide. Oh, okay, great. And so what we're actually seeing in our preliminary results is that this actually had a large impact on the propensity of treated users to post hate content. And we found a reduction of about 15% relative to control, which was primarily driven by the reduction in the spillover effect of having less neighbors, so other users that you're interacting with, posting hate content. So that's all I had, and I'm going to give the floor to Philippe.
Yeah, thank you, Sam. So one of the natural extensions when thinking about social media for us was misinformation, particularly since we had such a rich set of information already in the space. Maybe by a raise of hand, who believes to have encountered misinformation online when browsing Instagram, Twitter, Facebook, even the news? Anybody encountered anything? Right, so I think I don't have to make a case of why this is important. And likewise, it's important also in the context of development. I think there's emerging reports more and more clearly trying to outline the risk with regards to conflict by steering negative sentiments against minority groups. And thereby, the case is clear of why we, as development practitioners, should care about this. Now, we also know for everybody who has seen all these different posts that might be misinformation, that it is sometimes a pretty complex and nuanced task of detecting what is misinformation, what is not. But we thought a bit about, okay, what are the information we already know? We do already know that certain information sources have varying degrees of trustworthiness. A peer-reviewed journal article we probably trust more than a random social media user posting something about Bitcoin. At the same time, we also do know about certain claims that are certainly false or true. We have a bit of an understanding of certain scientific facts, historical figures. And at the same time, this is very unique to the data set we have access to. We have a pretty good sense of the content different users are exposed to, and also the network within which they operate and within which the information is being propagated. Now, we thought about how can we take these different strings of information and combining them into a system of trying to detect and understand misinformation in Nigeria. So with this pool of information, largely the social media data that Sam was referring to before, but also other data sets, including information about fact-check claims from a large set of NGOs that are operating globally, some of those that Daniel was mentioning in his task. And we then do a bimodal approach. We try to identify which misinformation topics are prevalent, that is in space and in time. What are people talking about? Which fake claims are being propagated to which extent? And at the same time, we're also trying to identify this then. Given the time limits we have right now, I'm happy to answer questions further after the talk, but we're basically going about this in two ways. We're trying to identify fake claims via semantic similarity, and we're also trying to understand which domains that are known to be untrustworthy are being propagated in which manners, which will hopefully help us to understand the information landscape and also identify users that are relevant in this space, that is information super spreaders, but also people like you and I that might be convinced by a post that is not very clearly misinformation, and then hopefully inform effective interventions that we can design, such as the one that Sam presented. I'll just skip forward to highlight also the larger team we're working with. A big shout out to a couple of people that are also in the room here today. And please feel free to follow some of the other work we're doing, such as what Karim was presenting this morning via the QR code. Thank you.
I don't know how much time do you have for questions. Do you allow how many? 5 minutes for questions, okay. Any question? Yes, one, another one, two there. We'll go in that order. Any other question? Let's go to that order and we'll see how many more questions will come. Thank you.
Okay. Hello. Thank you for all of your talk. It was very inspiring. My name is Mina. I'm a second-year data science for public policy student at Georgetown. I have more a specific question for, like, Songhyun. I think for your research. I have two questions. First of all, is about how you categorize the labels. I could imagine that I think we all already talk about the importance of context and understanding what the message is trying to convey. And then, for example, I was thinking was like Black Lives Matter versus like All Lives Matter. It might be people might think All Lives Matter might not be a a racist comment, but like if you actually ask someone who is completely out of the context, they might think, oh yeah, it's actually like it's not relevant to like racism. So, and I think it's might be relevant for our context, since I realize a lot of labeling is happening more globally. So a lot of people who are doing the labels are not the people who understand the context. So I'm curious, like, because I think that could be like something that could change the numbers a lot. Like, I wonder, like, your opinion on that. And my second question is about the cognitive, like, empathy part, like how you try to invoke people to be more cognizant of, like, of the different biases. Like, similarly to the context, it's going back to like how contextualized it is. Like, I would imagine, this is personal experience. Like, when I decided to study abroad in Ghana, my mom had a very different picture of where I'm going compared to what I had, and my imagination of what I feel the experiences of like my study abroad, and then we think we would write very different things about on the paper, and then that will also invoke different stereotypes. So I wonder, when you're doing that exercise, like what was your perception on those like different ideas and biases? Thank you.
Thank you very much. Can we take a second question so that we can have that round of question answered?
Hi, my name is Ujin Jung, and I'm at Rutgers. I have a question about hate speech project. So you mentioned that you were able to generate synthetic hate speech. I think it's similar to maybe image contexts where we can use like GAN to generate fake images to increase number of training labels. But in that case, we have to, how do we verify whether the synthetic training data is really good enough? Usually in our case, we use human to verify, but I mean, like, do people agree on whether that synthetic data is real, like very, real like, or maybe not very, authentic? And then just another question is, why did you choose Myanmar? Because it's like authoritarian government, military regime, so a lot of people may not be freely express their opinion compared to, maybe in other countries, more democratized. So.
Thank you very much. I will lend you my mic.
Okay. So if I remember the context, so there was first, yeah, I apologize if I have a bad memory. So the first question was about whether there was a context. And the second question, so how do we consider about the context? Like,
how context will make it like labels in a classical labels.
Okay, so let me introduce about a few things. So first, context is very important. I agree with you. But in the real case, when we actually train the BERT model, actually the context is often disregarded as well. So what we are trying to do right now is that apart from the context, how much we can actually improve the quality of the labels. Because it's not us that we are not I'm not saying that we should ignore the context, but oftentimes there are universal languages that has embedded meanings inside them. For example, in the example that we just showed, like if we were saying that the females matter, if they were saying that there was like Black Lives Matters and All Lives Matters in those contexts, we know the context is All Lives Matter is against the Black Lives Matters campaign, and that's why there is some problems with those statements. But apart from that, so can you say that will you label All Lives Matter as racist?
Well, but like if it doesn't capture, like how would it be applicable?
So I agree with you that there is some context that we have to capture, but having a context, so still apart from the context, there are things that are embedded that we have to evaluate further, label first. So compared to All Lives Matters, there is much more racist things that we have to first identify and first moderate. And I mean, what I meant by that is that actually context is more about the political things that you actually have to update all the time. And that is different from what we can universally use for the labeling. So yeah, sorry if I didn't. I hope I'm answering your question.
Yeah. If I I'm gonna just like say one comment, and I hope I don't take too much time. I think then imagine a situation that obviously I'm more of a believer that it's impossible to have a contextless situation. And if for example, if it's for my example, like it's probably easy way to implement that because it's probably happening in the U.S. and everyone knows about it. But probably if you want to apply that into like a different context, like do you understand the ethnic conflict in like different countries? I think like that type of labeling in somewhat is also capturing those biases because there's always this vague line. So I don't know. I'll just like put it over there and then.
Okay, so let me just briefly insert it and then just sorry. So first, in our experiment, so that's why we actually removed all the context. We actually curated all the sentences that are out with that you can understand without the context, and actually we limit the sample size. And we would be happy to like discover how different cultures react to different statements. And for the cognitive empathy part, actually the goal of the cognitive empathy is to make you think about other people, not about so. It is true that different people will say different things about what is marginalized group and why they are doing it. And there are a lot of people who are trying to say that they are marginalized groups, so they don't have to think about it. But as the goal of this empathy priming is that we think about other people, and it improves your quality of label. So I hope I'm answering questions. Thank you so much.
Can you pass the mic to
Sure.
Thank you very much for your question. So the second question is why Myanmar, given that it's authoritarian and all of the issues, and that's a very good question because that changed in January 2021 when the coup happened after the elections, and the project started in 2020 when Myanmar was still a democracy. So in 2017, due to hate speech on Facebook, it led to the genocide that was widely talked about. And so in 2020, civil society organizations were happy to avoid or hoping to avoid a repeat of what happened in 2016, 2017. And that led to the partnerships, and that led to the hate speech monitoring project that I worked on. So we were able to actually identified a large number of hate speech that was being missed by platforms like Facebook and Twitter in Myanmar, even though they claimed that their models were working 98% accurate. Of course, anyone who works in this space knows that's a lie. But I'm just trying to say that the coup happened after the project. We were doing this in a democratic state at the time. For the first question about the generation output, so I would say there are two ways we approach that. So unlike the GAN case where you're trying to generate visual examples that to some degree need to make sense to the user, for us we were looking for examples that would have predictive value more than readability, right? We didn't want a case where the goal is that you're able to generate lots of synthetic hate speech so that you can automatically use a bot to post it everywhere. So our goal was, if this gives us predictive ability, it's good enough. It doesn't have to be readable in the sense that you should be able to send this to somebody else. You certainly would find examples where it's readable, it makes sense, like someone would be offended in the other context. It doesn't happen all the time. But all in all, it improves performance when you compare it to machine translation and the other method. Thank you.
Any other comment that you want to add? You want to add something? No, I was trying to. Unfortunately, we don't have time, but it gives us an opportunity maybe after the session, like during coffee break, to actually continue talking. So let's put our hands together and then congratulate our speaker. Thank you very much for a very exciting panel. Thank you.